a block is attached to the string, and it's rotating around in the circle here at this particular speed. We know the mass of the string and we know the mass of the block. But we're trying to figure out if there was a wave going from the center to the end of the string here, and it was going at a particular velocity. We want to figure out how much time that wave would take to get from there to there. We know the velocity of this kind of wave is going to be the square root of t, which is the tension, divided by the mu, which is a mass per length. So we're basically trying to figure out what these two things are. Now, mass per length is simply going to be m divided by r because, well, this is the radius of this circle here. So that would be the radius. That would be the length that we're dealing with. That's the length. So we can kind of, and the mass is going to be the small m because that's going to be the string. Makes sense. So we can use that for the mu. Now, as far as the tension goes, the tension is going to be the centripetal force that is holding this stuff together. So Fc. Now we know from our calculations that Fc would be m vt squared over r. And we can also say W equals Vt over R. So we can make some substitutions. We'll be able to come up with the mW squared times R for Fc here. And that is actually going to be the tension that is in the string, because that's what's pulling this outward, and that's what's causing it to be moving around that way. That's the tension of the string. It's the centripetal force. So now we can plug that into this equation over here. We get the velocity is going to be equal to square root of the tension, which is going to be mW squared R. And that's actually a capital M because it's the mass of the block that's we're dealing with here. And then we can divide that by the small m over R. And we can see that the R would essentially go on top here. We could square that. And then we would get this type of relationship where we would say that the square root of capital M over lowercase m, and then we have the W times the R over here on the outside. And that would be the velocity. But we also know that velocity is equal to length divided by time. And the length in this case is R. So we'll put that over here. And we're really trying to figure out what t is. That's the main goal, t. So let's get rid of these r's and flip everything around so that we have t is equal to 1 divided by the square root of capital M over lowercase m times that w. And if we plug this into our calculator, we should be able to get that the t is equal to 0.00748 seconds or so. So that's pretty cool.